In this video, we're looking at the intersections of straight lines and circles. Whenever we have the intersection of two graphs, to find the intersection, we solve the simultaneous equations. And when we've got a straight line and a circle, so we could have two places they intersect. So the straight line can go through the circle. That means they intersect twice. The straight line could miss the circle entirely. There could be no intersections. Or it could be a tangent and it just touches the circle and then keeps going. So it could have one intersection, two intersections, or none. So whenever we are finding the points of intersection, we're solving the simultaneous equation. So we've got x plus y equals 5, and we've got our circle. To solve it, the easiest way would be to substitute. So rearrange to make the linear equation equal to y or x, make y or x the subject, and then substitute that in. So if I take x away from both sides, I can say y is equal to 5 minus x, and then I can substitute 5 minus x in for y. So if I substitute 5 minus x in for y, I'll have x minus 1 squared still, plus, and instead of y, I'm writing 5 minus x. So 5 minus x minus 3 squared equals 41. So now I need to simplify and expand the brackets. So x minus 1 squared is x minus 1 times x minus 1. If we expand that, we get x squared minus 1x minus another 1x plus 1. And then our second bracket, if we do 5 take away 3, that's 2. So it's 2 minus x squared. And we need to expand and simplify that one as well. So here I've got minus x minus x. I'm going to write that as minus 2x. And expanding the second bracket, so I'm going to have 2 times 2, which is 4. 2 times negative x is negative 2x. Negative x times 2 is negative 2x again. And plus x squared equals 41. So now I'm going to collect all the like terms. I've got 2x squareds. I've got minus 2x minus 2x minus 2x. So that's minus 6x. And I've got 1 plus 4, which is 5. And I've got a 41 on the other side. So 5 take away 41 is negative 36. So it's equal to 0. That's what I want for a quadratic. I'm going to half them all. So I'm going to have x squared minus 3x minus 18 equals 0. And then this is one that factorizes. We could use the calculator at this stage, but this is a 3 and 6. So it's x plus 3, x minus 6. So we can say x is equal to negative 3, or x is equal to 6. And we know y is 5 minus x. So 5 minus 3 is 8. And 5 minus 6 is negative 1. So they intersect at negative 3, 8. And 6, negative 1. Okay, one for you to try. Give it a go. So find the coordinates of the points where the line y equals x plus 2 meets the circle x plus 5 squared plus y plus 1 squared equals 10. So it's already in the form y equals, so we can substitute in for y. So I've got x plus 5 squared, I'll just write that out again, plus, and I'm changing y into x plus 2, so it's x plus 2 plus another 1 squared equals 10. So x plus 5 squared, if we expand and simplify, we should get x squared plus 5x plus 5x plus 25, and x plus 3 squared. If we expand and simplify, x squared plus 3x plus 3x plus 9. So that should give us, simplifying these, 2x squareds plus 16x's plus 34 equals 10. So we're solving a quadratic, make it equal to 0. So that's taking 10 away from both sides. And then again, we can make it easier by halving each term. And this one factorizes, so it's 6 and 2. So x plus 6, x plus 2. So x can be negative 6, or x can be negative 2. Y is x plus 2. So negative 6 plus 2 is negative 4. Negative 2 plus 2 is 0. So the intersections are at negative 6, negative 4, and negative 2, 0. This question says show that the line y equals 2x minus 1 does not meet the circle x plus 4 squared plus y minus 2 squared equals 20. So the line does not meet the circle. That means there are no solutions. These simultaneous equations have no solutions, and we can show that using the discriminant. So we're going to try and solve them and then show that we can get no solutions. So the first step's the same. We're going to take our straight line and substitute it in to the circle to eliminate y in this case. So I'm going to have x plus 4 squared, and I'm going to change y into 2x minus 1. So 2x minus 1 minus another 2 squared equals 20. So I'm changing 2x minus 1 minus 2. That's the same as 2x minus 3. And then I'm going to expand and simplify these brackets. If it helps you, you can write them out as 2 separate brackets. I'm not going to do that. I'm going to go straight to the expansion, but it's no problem if you do. So x plus 4 squared, x plus 4 times x plus 4 is x squared plus 4x plus another 4x plus 16. And 2x minus 3 times 2x minus 3, 4x squared minus 6x minus 6x plus 9. And that's still equal to 20. Collecting the like terms, I've got x squared and 4x squared. So I've got 5x squareds. I've got 4x and 4x, which is 8x. Take away 6x, so 2. Take away another 6, minus 4x. I've got 16 and 9, which makes 25. Take away 20 is 5. And that's equal to 0. So if this has no solutions, the discriminant b squared minus 4ac will have to be negative. To have no solutions, the discriminant is negative. So let's have a look. So b is negative 4. So it's negative 4 squared minus 4 times 5 times 5. That's 16. Take away 4 times 5 times 5, which is 100. And that's negative 84. So b squared minus 4ac is negative, therefore there are no solutions. One for you to try. Pause the video and give it a go. So show that the line y equals x minus 8 does not meet the circle. X plus 2 squared plus y plus 5 squared equals 9. So try and solve it. Substitute y in. So substitute in for y. That's x plus 2 squared. Change y into x minus 8. So x minus 8 plus 5 squared equals 9. So x plus 2 squared. Negative 8 plus 5 is negative 3. And then we need to expand and simplify. So x plus 2 squared is x squared plus 2x plus 2x plus 4. X minus 3 squared is x squared minus 3x minus 3x plus 9. And that's still equal to 9. So collecting like terms, we've got 2x squareds minus 2x's. We've got 4 plus 9 minus 9, which is plus 4. So they do not meet if b squared minus 4ac is negative. So b is negative 2. B squared minus 4 times a times c. So negative 2 squared is 4. 4 times 4 times 2 is 32. So 4 take away 32 is negative 28. So the discriminant is less than 0. Therefore, there are no solutions, no intersections. The line y equals x plus 5 meets the circle with equation x squared plus kx plus y squared equals 10. Exactly 1 point, find the 2 possible values of k. So if it meets at 1 point, there is only one solution. So b squared minus 4ac will be equal to 0. So again, we'll try and solve it, and then use the discriminant to find out what k would have to be for b squared minus 4ac to be equal to 0. So to find the intersection, substitute x plus 5 in for y. So we have x squared plus kx plus changing y into x plus 5. So x plus 5 squared equals 10. Expand and simplify the bracket. So x plus 5 times x plus 5. Again, if you want to write it out as double brackets, it's no problem. X plus 5 times x plus 5. So x squared plus 5x plus 5x plus 25 equals 10. Collect the like terms. So we've got 2x squareds. We've got kx plus 10x. And I'll just write them as 2 separate terms first. So kx plus 10x. And we've got 25 take away 10, which is 15. I want to know what a, b, and c are. I can't have kx and 10x, so I have to write it as one term. So you can think of it as factorizing out the x. So you can take x out of both of these terms. So you've got 2x squared. So if you take x out, what's left? You've got k plus 10, lots of x, plus 15 equals 0. So now we know what a, b, and c are. We know b squared minus 4ac has to be equal to 0. So b squared, k plus 10 squared, minus 4 times a, which is 2, times c, which is 15, must be equal to 0. K plus 10 squared is k plus 10 times k plus 10. So that's k squared plus 10k plus 10k plus 20k plus 100. And we've got minus 4 times 2 times 15. 2 15s are 30. 4 30s are 120. So we've got k squared plus 20k minus 20 equals 0. Can we factorize it? Not sure. Let's use the calculator. So a is 1, b is 20, c is negative 20. So menu, equation or function, polynomial, degree 2. So it's 1k squared, 20k's, and negative 20. So we've got k can be negative 10 plus 2 square root 30. Or negative 10 minus 2 square root 30. So they are our two solutions. One for you to try. Give that one a go. So the line y equals 2x plus k meets the circle with equation x squared plus y squared equals 16, exactly 1 point. So again, the discriminant equals 0. It's got one solution. Find the two possible values of k. So let's solve it. So substitute 2x plus k into the circle. So we've got x squared plus 2x plus k squared equals 16. So expanding and simplifying, we've got 4x squared. So 2x times k is 2kx. And then k times 2x is 2kx again. And then we've got k squared equals 16. So we have 5x squareds. We've got 4kx's. And we've got k squared minus 16. So that is c. So a is 5, b is 4k, c is k squared minus 16. We know b squared minus 4ac equals 0. So that means 4k squared, 4k times 4k, minus 4 times a, which is 5, times c, which is k squared minus 16, equals 0. So 4k times 4k is 16k squareds. And we've got negative 20 times k squared, negative 20k squared, and negative 20 times negative 16 will be positive. 20 times 16, that'd be 320 equals 0. So we've got minus 4k squared plus 320 equals 0. So that means 4k squared equals 320. Divides both sides by 4. So k squared is 80. So k can be plus or minus the square root of 80. This one says the line y equals 2x minus 1 does not meet the circle with equation x squared plus 2x plus y squared equals k. Find the range of possible values of k. So it does not meet them. does not meet, so the discriminant will be negative, less than 0. So let's change y squared in our circle equation into 2x minus 1. So x squared plus 2x plus 2x minus 1 squared equals k. So x squared plus 2x, and then expanding and simplifying the double brackets again. So if you want to write them out, please do. We've got 2x times 2x, which is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x again. Negative 1 times negative 1 is a positive 1. So collecting the like terms, we've got 5x squareds. We've got 2x minus 2x minus 2x. So that's negative 2x. And then we've got plus 1 and take away k. So 1 minus k. That's our c. So a is 5, b is negative 2, c is 1 minus k. We know b squared minus 4ac is negative. That's negative 2 squared minus 4 times 5 times 1 minus k. B squared minus 4ac is negative, less than 0. So negative 2 times negative 2 is 4. Negative 4 times 5 is negative 20. So negative 20 times 1 is negative 20. Negative 20 times negative k is positive 20k. So we've got negative 16 plus 20k is less than 0. So plus 16 onto both sides. So we've got 20k is less than 16. Divide both sides by 20. So k is less than 16 over 20. Or 8 over 10, or even better, 4/5. So k is less than 4/5. One for you to try. Pause the video and give it a go. So the line y equals 3x plus 2 does not meet the circle with equation x squared plus 3x plus y squared equals k. Find the possible values of k. So it does not meet the circle. So b squared minus 4ac is negative. So to find the intersections, substitute our linear into our circle. So we've got x squared plus 3x plus 3x plus 2 squared equals k. Expand and simplify the double brackets. So that would be 9x squared plus 6x plus 6x, so plus 12x plus 4. So we've got 10x squared plus 15x's plus 4 minus k equals 0. B squared minus 4ac is negative. So 15 squared minus 4 times 10 times 4 minus k is less than 0. So 225 minus 40 times 4 minus 160 plus 40k is less than 0. 225 minus 160 will be 65. So take 65 away from both sides and divide by 40. So negative 65 over 40 which can be simplified to negative 13 over 8. So that's our answer.